Well, welcome everybody to today's webinar, Drone Earth Observation, Critical Pillars in Earth Observation Sciences and Applications. A particular welcome to our panel of expert speakers and welcome to those of you who are joining the webinar from all around the country. I'm Megan Lewis, Acting President of Earth Observation Australia. This webinar is the second in a series between now and June this year, leading up to the Advanced Earth Observation Forum to be held in Brisbane, 22nd to the 25th of August this year. These webinars are aiming to engage you in some hot topics in Earth observation and to build connections in our Earth observation community in advance of the forum later this year. In opening the webinar, I'd like to acknowledge the traditional custodians and lands of the waters and of all of Australia, the country on which we live and work. I offer my respect to elders past, present and emerging, and aim to build our shared knowledge and experiences. I'd also like to remind participants of our Earth Observation Code of Conduct for this event, and you can find that on the Earth Observation Australia webpage. In essence, please be professional, considerate and respectful to others, and open to discussing ideas and from a diversity of ideas and perspectives. A few housekeeping points. Please note that the session is being recorded, and because of the large number of participants, please keep your webcam off. Please post any comments or feedback in the Zoom chat, and there will be a moderated question and answer session during the webinar. So now I'd like to hand over to Dr. Renee Bartolo, and I'm just checking that Renee has been able to join us and that she'll be able to moderate the next. Yep. Renee is there, terrific. Good to see you, Renee.
Thanks a lot, Megan.
Renee holds the very impressive role and title of Chief Remote Pilot for the Department of Agriculture, Water and Environment and Landscape Ecologist in that department. She's worked in the top end for the past 15 years, and in her role as Chief Pilot for DAWE, she established a drone program 6 years ago. So Renee, I'll hand over to you to introduce our other speakers and to moderate our special session. Thank you.
Many thanks, Megan, and it's great to see so many people online for today's webinar. And I'd like to also thank our three guest speakers today for agreeing to come and present as well. So yeah, today we're going to be having these presentations around drones and how they're an important pillar in the Earth observation community. So we're very fortunate to have Arko come along and give us an update on the National Terrestrial Ecosystem Research Network's what they're doing around ecosystem monitoring using drones and data collection. And then we have Jason Barnetson as well, talking about, from a government perspective, the challenges and constraints to using drones for quantitative environmental monitoring. So the focus of these presentations is around that quantitative environmental monitoring. And then the last speaker will be Christine Lachlan, Christine Lachlan-Arrowsmith, who works for Streamology, and they'll be talking, and she will be talking about how they use drones to monitor for soil and plant aspects in water flow management. And yeah, very excited to be listening to what they have to offer. So without delaying things any further, I'd like to introduce Professor Arko Lucieer from the University of Tasmania. He's the Deputy Head of School for Geography, Planning and Spatial Sciences. He leads the Terraluma research group, focusing on the development and application of drones, sensor integration and image processing techniques for environmental, agricultural and high precision aerial mapping applications. Arko also teaches remote sensing and GIS at the university at both undergraduate and graduate levels. And his current focus is on remote sensing of vegetation and biodiversity with the use of sophisticated drone sensors to better understand the structure, distribution and functioning of vegetation and to bridge the observational scale gap between field samples and satellite observations. So take it away, Arko.
Great, thanks Renee, and thanks to the organisers for putting this together and for the invite. Just checking that you can hear me okay and see the screen. All good?
Yep, that's great, Arko. Thanks.
Great, thank you. Yeah, so I'd like to provide an update on our activities within TERN over the last year. And I'd like to acknowledge Purnima, Bethany, Darren and Emiliano as key contributors. So the main goal of the drone sub-program within TERN is to essentially set up a series of monitoring protocols and data collection protocols to allow for robust data collection. So the aim is to collect long-term ultra-high resolution data that fills this scale gap between field observations and airborne and satellite observations. And for that to work well in a monitoring context, we need protocols so that multiple teams can collect data in a robust manner that facilitates monitoring. We also need standardized metadata collection, testing of data uploads of large data sets, data management, and that also means training of TERN users to really broaden that activity across the country. So just an overview of the current equipment that TERN has funded and that we're sort of building as a capacity. So we're after a platform that's robust, yet still portable, with high quality sensors that can be used for ecosystem monitoring. So we settled on the DJI Matrice 300 RTK. So quite a long flight time, supports dual frequency GNSS, obstacle avoidance, terrain following, and so on, and can carry multiple sensors. This is the DJI ZenMuse P1. So it's a mapping camera, full frame mapping camera that allows collection of 1 centimeter imagery flying at 100 meters. So it's a sort of a dedicated mapping camera, which is quite exciting to see. And photos are geotagged with dual frequency GNSS. In the multispectral space, we use the Microsense Red Edge MX or the Microsense Dual, where Microsense have tried to map their bands to Lancet and Sentinel bands. And again, those two sensors, so the P1 and the multispectral sensors, can be flown simultaneously. So we focused initially on field testing of direct georeferencing, where our thinking is that field deployment of the Matrice 300 should be quick and easy without the need for ground control points, because that's often the most time-consuming aspect of field deployment. So in this test, we used ground control points for verification and basically tested the direct georeferencing ability of the system, which included a whole processing workflow to co-register multispectral to RGB datasets. We basically achieved a horizontal accuracy of 9 to 13 centimeters and quite varying vertical accuracies of several decimeters, even up to a meter for the higher flights. So we tried to improve that a little bit through elevation optimization, which is a new sort of tool in the flight planning. And that significantly improved the accuracies to 2 to 3 centimeters horizontally and 10 centimeters vertically. And clarifying that again, that's just without any ground control, where the ground control is only used for verification. So that's it's really encouraging, I think, from a TERN perspective. So here's just some examples. So it's a remnant a remnant vegetation plot on a farm. For scale, you can see our car there in the bottom left. And so, yeah, a lot of detail in the woody structure of the eucalyptus trees. Just an example of the 5-band multispectral data of the red edge. So here we're looking at near-infrared, red edge, and blue as the band combination. And just to give you an appreciation of the co-registration accuracy, here's an example of that same area in RGB and in multispectral. And I'll just flick back and forth a couple of times. So keep an eye on some of the branches, for example, and the tree crowns. So that co-registration accuracy of the two sensors is, I think, very encouraging for this sort of level of resolution and the ecosystem monitoring applications in mind. So we're developing these data collection protocols. So these are documents that are currently under review, and they'll be publicly available as part of TERN. That include things like pre-flight checks, flight planning, so really practical documents of stepping through the data collection process. Then the data processing protocols at the moment focus on Aegis of metashape and include quite a few pre-processing steps using Python scripts to interpolate coordinates to really allow for accurate co-registration. And again, the intent is to publish this in the open domain through TERN. In 2022, we'll be looking at things like options for atmospheric correction, optimized workflows for different types of vegetation communities with varying heights and complexity. And then we'll be focusing on higher level derivatives, sort of level 2, level 3 derivatives in terms of vegetation indices, fractional cover, and structural properties. We're also working with the TERN data services team to sort of optimize the transfer of raw data and processed data products to the TERN portal. And we're working with them to make that process more streamlined. As a side project, we know that a lot of people in TERN, including the surveillance team, are really interested in vegetation structure, and that's notoriously difficult to derive from optical imagery. So we're currently trialing a new laser scanner for the DJI Matrice 300 called the ZenMuse L1, and that's built on that same RTK system. So for that same plot that I just showed, here's just some initial point clouds, and it's always challenging to get a feel for point clouds on these static slides, but I'll do my best. So you can see the branching structure in these crowns. This is up to 3 returns, so return numbers are shown here. Return intensity, maps RGB data, so RGB from the onboard camera as well, and then back to height. So we'll be looking at, again, data collection protocols to make the collection a standardized exercise, but also the process for derivatives, structural derivatives from these LiDAR point clouds. Just a couple of other initiatives. So in TERN, we've also committed to flying sort of high-level sensors like hyperspectral sensors and LiDAR sensors over some of the super sites. So this is an example of our latest hyperspectral payload, SpecM FX10 and the FX17. And some examples of, in this case, a project that looks at the detection of ancient huon pines in Tasmania, where we really need that combination of high spatial resolution, high spectral resolution to identify these target species. Perhaps also interesting within a TERN context, we have a project with Stuart Finn at UQ that looks at biodiversity assessment and using drone technology to look at deriving functional diversity metrics, in this case from hyperspectral data, looking at different physiological traits like chlorophyll, anthocyanins, and PRI. So finally, we've built up a sensor calibration facility here at UTES. So this is just an opportunity to highlight the fact that we have this calibration facility and that it's accessible for others to come and calibrate their sensors. And I'd like to finish by saying that this year we're continuing to work on automated processing workflows to produce robust analysis-ready data sets for ecosystem monitoring. We're then sort of transitioning to these high-level derivatives, vegetation indices, fractional cover. We're looking at and exploring LiDAR and data collection protocols and structural derivatives, and then continuing to identify physiological traits. Some of the key challenges include beyond visual line of sight operations in forested environments. It's mainly a challenge with the regulation. But also data handling. We're collecting lots of data in a short amount of time, and making these data sets available is still not a trivial exercise. And of course, that last one is important, and this is where collaboration is essential, the extraction of ecologically meaningful data from remote sensing data sets. I'll leave it there. Thanks very much for listening, and I'll hand back over to you, Renee.
Thank you, Arko. So that was really great. And at the end of the 3 speakers, we will have a Q&A panel. So you can ask Arko some questions at the end of the presentations. Thanks, Arko. Okay, our next speaker is Jason Barnetson, and he works for the Department of Environment and Science in Queensland in the field of environmental and rangeland management, and he's been in the field of environmental and rangeland management for over 25 years. As a senior scientist with the Queensland Department of Environment and Science, he has undertaken numerous projects in the environment fields involving research into the various techniques and methods developed to remotely sense rangeland landscapes. So thank you, Jason.
Thanks, Renee. Thanks, Arko. That was awesome. It's nice to know we are all facing similar challenges. Whoa. And one of them seems to be driving my PowerPoint. Okay. Yeah, so I work in, as Renee says, a government department, primarily focused on environmental monitoring using remote sensing technologies. We primarily work in grazing systems, but we do have a number of other activities, and I'll just talk a little bit here. So the grazing systems we work in range from dairies to grasslands to more broader rangeland environments. But we also are part of a team that looks at mapping woody vegetation and some environmental monitoring here, waste levy monitoring. We're also involved in a number of satellite calibration validation exercises. Here we're collecting Landsat 9 calibration data with both the proximal sensing and hyperspectral sensing out in Western Queensland. Some of the technical challenges include the complexities of systems. So this is my desk any day. There's many moving parts to these systems, and amongst other tasks, there's unique skill sets, and finding people with those skill sets can be a challenge. They're custom off-the-shelf systems. Nice to see, Arko, you found a solution that is off the shelf, but I'm sure that comes from many years of customizing and working up a system. So we're still in that stage. We're building these off-the-shelf systems. There's a mountain of equipment that we lug around here or out in Western Queensland with, you know, a vehicle with many spares, portable kind of repair workshop. It's not easy to get fixes and parts out there, so we carry a mountain of gear, which can have its own challenges. So at the moment, we're still in this stage of collecting both field data and UAV data, and we're bridging the gap, I guess, between the field and the satellite with the drone data. And so we've essentially doubled our effort and or increased our effort. In terms of wrangling data, as Arko suggested, there's terabytes of data that needs to be handled and managed carefully in the field. And so that presents its own unique challenges. They're high resolution data sets, often, you know, in the 1 centimetre or even sub-centimetre scales. So handling those data sets and having the compute resource to process those data sets. Here we've invested in a kind of high-end desktop system, but we're hoping once we work through using commercial systems, commercial software platforms, process the data, that we'll move to an open source system that will allow us to do processing on our high performance compute facility. So having the skill sets, you know, there's a number of different areas of remote sensing here: photogrammetry, hyperspectral sensing, more recently machine learning techniques. So finding the people to have those skills or building the capacity so that we can have the capacity to process the imagery is a significant challenge. So we talk about bridging the gap. More recently, we've been trialing a number of different proximal sensing techniques, and that's taking, you know, a real world physical measure to another technique of remotely sensing, and then scaling that to the drone and then ultimately to the satellite. And the challenges presented in doing all of this are about having systems, having repeatable systems, so having good ground control, having good calibration, and having good documentation so that we can repeat measurements on our monitoring sites. So with, you know, denser measurements, we have this signal in the noise scenario. So in lots of situations or examples, there's, you know, hundreds of data points, if not thousands or millions, and just teasing out that signal from the noise is a challenge. And so that requires different techniques in not only capturing the data, processing it, but then what are the techniques to tease that out? And so we've gone from this concept of a simple model to a very complex data-driven, dense data-driven model. And that's where some of these modern machine learning techniques are coming into their own. Innovation in a bureaucratic system, documentation is something that we all need to do, and risk management. We all want to fly legally and safely. Governments often overcomplicate some things, but having a pragmatic approach that keeps everyone safe and legal, but is efficient and just, you know, we've doubled our effort, so it's just increasing our workload. So that pragmatic approach is important. Managing expectations. You know, drones are often seen as the end solution to fix all our woes. They're not, they're just another tool in the kit. And being able to communicate that is sometimes a challenge. Challenging some attitudes towards technology. Here we've got Lord Byron and the Captain Ludd and his Ludds that smashed all the looms in the Industrial Revolution, and that was a fear of change and a fear of technology. So, you know, just managing that change and making sure that the people who are involved in that change are supported and feel embraced in making those changes. And most importantly, my biggest challenge or constraint really is keeping trim on the road with all the yummy tucker in Queensland as we travel around the state. A few examples there. And some shameless self-promotion. Here's a couple of publications. One using hyperspectral and photogrammetry to look at pasture quality and quantity across the Queensland rangelands, and then a more recent publication of last year, so people can check those out. And that was looking at how we bridge that gap, how we scale to the satellite, and using some more modern deep learning, machine learning techniques. And that's me. Thanks, Renee.
Thank you, Jason. I love your one of your issues is keeping trim on the road with all the food that you come into counter with. Sorry, I've just got some issues with my camera. I'm having lots of battles with Zoom today, so my apologies. I will just continue to introduce, so thanks, Jason. I'll continue to introduce Christine. So Christine, thank you for joining us today. And she is coming to us from Victoria, right?
Yes, that's us.
She's an experienced waterway and coastal engineer with over 23 years industry experience. She's worked on a range of projects from flood studies and eco-hydraulics to waterway, geomorphology and urban stormwater investigations. Her skills include the ability to lead teams of technical professionals to answer challenging waterway management questions. And some of the recent projects Christine has worked on have seen her combine this very experience with new tools such as drone data capture and spatial analysis to develop approaches which improve how we manage waterways for both now and into the future. Take it away, Christine.
Thank you very much. I'll just put my presentation up now and hopefully that works for you all. I'm just so jealous of Jason and Arko with the wool gear they've got. What I'm bringing to you today is probably more on the applied end of the spectrum. So Streamology is a small consulting company in the waterways, predominantly waterways and geomorphology sort of space. And we've got a team of people that's really keen to apply technology, particularly those that have been coming through the university systems in the last 5 odd years that have had exposure to drones and using that sort of technology and want to put it into practice and helping us to improve how we manage our waterways and our wetlands and our systems, and how we can help land managers do that in a practical way. My background is engineering, but we have a team of environmental scientists, geomorphologists and spatial analysts. And I would like to acknowledge Jeff Beats, who is our director, who set up the sort of drone analysis that we've been doing, and a number of the team, Neil and Tom in particular, who have been really critical in developing up some of our work. And I'm sure they're going to be keen to look up a lot of that work from TERN and other areas as well to sort of help improve what we do. So what are we trying to understand? The idea for us is to improve how we manage our waterways so that we can get better outcomes, both from a geomorphological sense, so the landform itself, down to the vegetation and the flora and then the fauna that are also in our waterways. So platypus are a big one down here in Victoria at the moment, improving waterway outcomes. And there's a lot of issues in some of our waterways towards the north of the state where they're managed systems where we deliver environmental flows or irrigation flows and that sort of thing. And there's a lot of concern around processes that occur in the waterways like erosion and how we can link that better to the drivers of change. So these are things like the flows that are in our river systems. And as I said, you might have irrigation flows and then you might want to deliver environmental flows as well. And we see considerable change in the waterways between these different types of flow event. And a really interesting one that's come up a lot over recent years has been the impacts of vessels and vessel wash on our waterways and erosion of banks and things like that. And I've got a couple of good pictures of some work we've been doing in that space. And wanting to represent patterns of change. So we need to understand both at individual locations, but also more variably, spatially along our waterway systems and temporally over time. How do things change and what does that mean for how we manage our systems? And recognising the scales at which these things operate as well. So we might have a certain vegetation community in one location that we want to target with a particular action. How is that going to be affected by some of those other complementary measures or other things that have been going on? And it all leads us towards a more strategic approach to waterway management. So what's happened over time? So what's led us to drones really, and why are we thinking this is a really nice way to improve how we understand and manage our waterways? So if we go back, and it's not really that far, we used technology like erosion pins and transects. So these are cross sections, and these are sort of, you might see in the picture at the top, there's pins that you put into the bank itself, you hammer in, and then you measure the location accurately of each pin, and you go back over time and you see, okay, if the bank's eroded back, where is it now relative to the start of that pin and things like that. So these were ways of measuring and understanding erosion in our waterways. But as you can imagine, they're fairly limited spatially. You can't cover an entire bank, 50 metres of bank with erosion pins and have someone go back there and measure them, every day, that sort of thing. But the spatial and temporal challenges are quite high with getting good information out of it. And so having drone technology allows us to then go out and capture data along a whole section of bank or various sections of bank and under different conditions as well. And we can go back day to day if we really want to. And the data that you get out of this sort of technology as well, it really enhances our understanding and also the communication of that understanding. So helping people, just the general waterway officers and catchment managers understand what the impacts of their decisions are has become much more readily digestible by being able to put across things like 3D point clouds and digital elevation models, because we can show them visually what that change is. So we started off with from our erosion pins, we get numbers and charts, but that's really hard to communicate an outcome. So by having a point cloud and information from that, we're able to put that across more readily. So our drone monitoring, we're going down to quite small scales. We want to go into actually individual banks and look at things on a really detailed level. The reason being that some of these responses to flow happen at really micro scales. And so you can see the picture there is sort of a really detailed point cloud of a particular bank, and you can see a sort of failure occurring on part of that slope as well. And prior to that, the only tool that we had available was, our LiDAR data sets, which are 1 metre grids typically, unless you go and get the original point clouds. And even then, it's not giving us the sort of resolution that we needed to understand it at a spatial scale that we needed. And so that's where erosion pits had their place, but we needed something better. So what do we get now? So now we get these 3D point clouds that give us a really great picture of what a bank, or in this case, a bank looks like. And we can then compare images over time, or the points over time, and derive metrics around how much depositions occurred, how much erosions occurred, and what does that mean for what was happening in the river in those particular times. So we're at the off-the-shelf down at your local shop sort of end of the drone spectrum. So we want things that we can readily get hold of. If it happens to hit a tree branch and end up in the water, it's not the end of the business type scenario for us. So we want cheap and cheerful, but still gives us the level of resolution that we need to be able to make some of this, or create some of this understanding. So what are we doing? We're going out on site. We do put, we have RTK-based systems that we put, we also put ground control points out, and then we fly our areas that we're interested in, and this is bank surveys I'm talking about in particular here. So we fly them as if you're creating a 3D model, not as if, not an ortho mosaic or something looking from directly from above, but we want to give the detail around the actual form and some of that structure and you know, the branches, the actual material of the bank as much as we can. And so we fly it in terms of a 3D picture. To create a 3D picture or elevation model of point cloud sort of system, and we compare that over time. So they call them DMODs, digital elevation models of difference. And from that, we can then start to understand some of those metrics. So this is an example of erosion on a riverbank. So we've got 2 visits to this particular site, and the differences between those 2 visits are coloured in red and blue, and we're looking at erosion and deposition. And the key is obviously you need to align these carefully. You need to be really comfortable and confident that you're getting that alignment of results, because obviously you get spurious outcomes if you haven't aligned your imagery and your points properly. Because what we're talking about is trying to derive volumes of change and relate that back to flow conditions, and we don't want to over or underestimate just because we've offset our picture and that sort of thing. So we're looking for things that are accurate, but also informative. And that links us to the flow. So we can, by knowing what's going on in the river at that time, and we've gone out and taken our surveys, we link it to the change at a given flow condition. So in this case, you can see there that they've got flows at 1,100 megalitres per day, the bottom line, and then up to 3,000 megalitres, and they relate to things like an environmental flow release or base flow condition when you're doing irrigation delivery and that sort of thing. So trying to understand what each of those types of flows is doing is what we're trying to understand using the drones. And what we do is link that, so you can see areas of high erosion that might be related to a particular flow event. We might want deposition lower down, but we want to deliver seeds and have material, silty material deposited in those lower reaches. So what we're trying to do is understand from the flows, what's the change, where's the, what the flow is specifically doing for that. We can pick up if there's a problem related to a flow condition, and this is the case with prolonged irrigation flows. You tend to get these sort of notches form in the riverbank, and by understanding, what's the magnitude of that change going on. The one I was interested to see from both of our previous speakers is on a vegetation. So one work that's going on at the moment is looking at ground cover responses to environmental flows. So these are, how does the vegetation underneath the canopy actually respond when you put water into some of these red gum systems and wetland systems? And this is on the Edward Pool, just off the Murray, and trying to understand from different sites what's going to be the response when you put environmental water down it. In this case, there's 3 example sites, and within each of those sites, you see there's a whole lot of numbers here. So those are ground control field verification sites. So we have a team from the universities and the traditional owners, rangers from those areas are going in and doing field surveys, which we are lining up with our in this case, it's multispectral camera. And they're wanting to see, can we actually recognise some of these different types of ground cover? Can we look at it over different periods of time, so different times of the year, different flow conditions, and see what can we actually derive in a fairly simple manner, so that it could be used quite regularly for them to manage those systems. And the other fun one that I wanted just to throw up as well for everyone to listen to was around monitoring vessel wash. So many of you may have been out on the rivers during the summer break and seeing people out there with their boats, wake boats and things like that. And what we find on the Murray in particular is there's a lot of issues around erosion, and people do a lot of finger pointing, oh, it's the boats, they do this. But we haven't got any definitive information to say, yes, it's this type of boat, you need to control it to this sort of speed and that type of thing. So what we are trying to do is complement existing approaches like boat counts and erosion pins and things like that with really targeted drone monitoring as an experiment to help draw some of those strong linkages. So this was a field investigation, a field survey of a section of bank. We had 3 different types of boat that were running at different types of, or driven at in different ways to generate different types of wake. And what we did was do a whole lot of repeat drone surveys of the banks and look at what was happening. So this hopefully will show you a little bit of a GIF plotting some of that. So what they did was they had the different boats. They did sort of 50 passes of this bank to sort of speed up the process of what would be occurring over a few days, I guess, in reality. And then for the different boats, the different types of wake that they were creating, can we correlate that to a response in the bank itself? So trying to understand what they might be doing. And from that, you obviously can derive, those metrics of change. So how much erosion occurred in this case. You've got a wakeboard boat that's sitting that's generating quite a large wake behind it, and then you have it when it's just sort of cruising along as well, and you can really see the difference for those type of bank. And I would say that this is a fairly sensitive type of bank, so you wouldn't expect it on all of them, but there's a really obvious signature between boats and different types of boats, and also how they're operated. And we couldn't do it with just erosion pins or boat counts before because of that temporal and spatial resolution. So adding the drone to the mix just makes the picture a little bit clearer. It's not the be all and end all, but it's really helpful in improving understanding and drawing those linkages that we really need between it. So here's just a nice couple of shots of looking at the notch, which is the edge of the erosion scarp that you've got along the riverbank, and the bank profile is quite variable as well. And then we can derive, what happened after you've had that 50 passes of a wake boat. What happens? Is there a really direct response? Can we measure that using the drones? So in terms of what we're trying to do, we want snapshots of condition and understanding our processes a lot better. We want to know what's happening spatially and temporally. We want to be able to recognise patterns, so giving us something to help draw that linkage between the processes and drivers and the outcomes that we're seeing. And, so we can make sure that we can put forward management options for waterway managers or wetland managers, people like that, that will have a tangible outcome that they can predict and that they know what's going to be happening in those times. We want to make sure that then that leads to strategic management so that they are thinking ahead and have some tools in their toolbox to be able to do that. And of course, as the team always says, they want to create awesome images, videos and models, and that's what they love to do, but they like to draw that link to the science itself. So maybe can we improve the scientific outcomes? Can we improve how the public sees our systems? Can we communicate some of that change, some of those drivers, to make it more readily understandable to people in the street what's happening and what some of this technology can actually help us achieve in management of our systems. So I think that's a whistle-stop tour through a few different things. I hope it's been interesting really to look at a few of the applications. Future opportunities are just, the sky's the limit. No pun intended, or pun intended probably. So there's lots of things that we can do. It's just coming up with the great ideas and the great questions. So yeah, that's me. Thank you.
Thanks, Christine. That was a great presentation on applied erosion and vessel wash monitoring. I thought the vessel wash application was super cool. And I think it's always interesting to see how people approach the challenges in applied drone operations, because you have to make sure you're getting an end result. So that was great. I think Dan said it's great to see drones being used for some applied fluvial geomorphology.
Yep.
So now we'll move into the Q&A section of the webinar. So if people would like to either start dropping questions into the chat or I think put their hand up. Have we got that? Probably just put the questions into the chat window. Yep. Okay. Or you can raise your hand. So who wants to start? I know that Karen Joyce dropped a question into the chat for you, Christine, about what to know what the management outcomes are from demonstrating the erosion.
That's a good question. So on the Goulburn River, which is where we've done a lot of that bank condition monitoring, it's actually informed the flow regime. So the selection of flow regime to deliver environmental flows and deliveries as well. And so there's been a direct correlation between measuring the erosion, linking it to the flow regime, and then changing how we operate our systems so that we get a better outcome across that. It meets all the needs that it has to in terms of the water requirements, but also minimises potential damage or adverse outcomes for our ecosystems as well.
Javier's put a question in for you as well, Christine, wondering what altitude are you flying over the rivers and what type of vertical errors are you getting?
Yeah, so they're flying pretty close to the banks, so they're within a few metres at times of them. So we're aiming to create the 3D images, and to do that we have to fly, and we want sub-centimetre accuracy as much as we can for that, to get those sort of difference plots. So yeah, they're within 5 to 10 metres of the bank in many instances. And they're flying up and down sections of river. And so obviously trees and things in the way are critically important for us. And that's where it comes to having affordable technology, I suppose, as well, because there's always risk.
That's great. Okay, thank you. The next one is a question for Arko from Paul Branson. Could you speak to any integration challenges in using custom sensors, for example, the hyperspectral camera with the DJI platform? Specifically, did you need a secondary GPS for position and time syncing?
Yeah, great question. To give you an indication, we started this work in 2013 and we're on our 6th prototype now. And I feel that we sort of finally have it right. So it's taken us quite a few iterations. Mind you, we've done a lot of that integration ourselves out of individual components before off-the-shelf products were available. So it's sort of matching the hyperspectral sensor to a data logging unit to a GNSS IMU to allow for time synchronization and accurate georeferencing. So yes, we use a completely independent system from the drone. So we really only use the drone for as the hook in the sky, basically. And then we have sort of a modular payload that we can slide onto the drone airframe. So this is the DJI Matrice 600 I'm referring to for the hyperspectral payload.
Thanks, Arko. We might move to a question for Jason. When you were doing your rangeland biomass estimations, how did you adjust for soil reflectance? Was it M-Savvy as well? What computer specs are you running for your new machine, for your machine learning analysis, like the CPU and the RAM?
Yeah, awesome. So essentially, we've been looking at a mass to height relationship in terms of pasture biomass. We're just now starting to work into how the hyperspectral sensing can give us more spectral information. So we have both structure and spectral resolution. And yes, soil reflectance will be a component of that. In terms of CPU RAM from machine learning, so from memory, it's a fairly standard gaming type GPU, NVIDIA GPU. So most of our work has been in a regression kind of environment. And so having high GPU hasn't been that critical, but you know, when we move to an image-based assessment, then yeah, the GPU comes into play. Yep.
Thanks, Jason. Tim Malthus, you've got your hand up. Would you like to ask your question?
Yes, yeah, hopefully you can hear me. Just want to thank you all for the fantastic presentations. Really good, really interesting. My question is really future. I don't know who it's directed to, but I'd be interested in comments on when are we going to get to the stage of perhaps automated deployment of drones? You know, we're removing operators. I currently see limitations in terms of, you know, sort of CASA regulations that drones have to be in line of sight. But to me, when we're dealing with a large as Australia, we need those sort of drones. And in effect, you know, removing the human influence and the fact that we need an operator, you know, particularly close, but let's say covering, you know, wide swathes of Australia, we can really complement satellite data in that way. So I was just wondering, you know, how much of a limitation is spatial extent at the moment in terms of coverage, and when might we see, you know, CASA and the regulators actually catching up with the technology here to allow us to really embrace this technology Australia-wide?
Yeah, that's a good question. I'll have a go at that. So just before Christmas, yeah, thanks, Arko. Just before Christmas, I did some training into 2 classes. One is called Extended Visual Line of Sight, and that has 2 categories within it. And the other is flying above 300 feet. So it's very much a changing space. To give you an idea, beyond visual line of sight is out of the realm of most operators. You know, it requires an IREX exam, which is basically flying IFR. So it's, you know, it's kind of commercial pilot type training. However, indications are that some of those things will be relaxed, or there'll be systems and training in place throughout this year and into next year that'll make at least extended visual line of sight something that is more achievable for your basic operator. But yeah, you're right. It's a challenge, and it's something that I think people are asking. Renee's been down that road before and probably can comment a bit further.
Yeah, thanks, Jason. So we do have a beyond visual line of sight approval for our operations across the Alligator Rivers region. We got that last year, but yeah, we've got IREX pilots in the ops. So you know, we've had to go and do IREX, and I'm not really sure if that's going to change anytime soon. And we also wanted to get an approval to fly above 600 feet because when you're to sort of do these longer distances at the moment, the extent that you're talking about, Tim, you need to have sort of things like vertical takeoff and landing platforms or fixed wings, and the speeds that you fly at, you know, you need to sort of start going above the 400-foot limit, and they would only let us take a 600, a little sort of 1,000 hectare test site for the 600 feet. So, you know, not all, you know, we couldn't have the whole area like that. So, and in terms of removing people from the operations, yeah, that's starting to happen. I'm not sure how many people have heard about drone in the box, they call it. So there are some approved drone in the boxes, and I think I saw the other week that there's an approved drone in the box operation in a remote area. So that will start to become more common, but yeah, that's still like a sort of regulatory challenge, but they're starting to approve these operations. So I'm hopeful, Tim, in the next, you know, 18 months or 2 years, we'll start to see more.
You know, thanks for that. That's great answers.
Thank you. So we might just take one more question. There's so many great questions in here. So we've got another one here for you, Arko. Using the DRTK2 station, have you used a third-party receiver with the M300 RTK? Is the DRTK2 worth getting?
Thanks, Renee. I put my answer in the chat as well.
Oh, sorry. Yep.
So in short, yes.
Oh, cool. Thank you. I didn't see that. All right. Well, we might wrap up now. So I'd really like to thank Arko, Jason and Christine for your presentations. They were all very, very different, but very topical and on the whole sort of side of environmental monitoring. And I would like to also encourage everyone to attend our forum that we've planned for August. So that's the Advancing Earth Observation Forum, and part of that integrates the national UAS for RS conference, the drone conference that Arko and others had started off a few years ago, and it'll be really great to see people come along to that. And if you're really interested in running like a specific topic session at the UAS for RS component of the conference, or you've got some ideas for presentations that you'd like to see, please contact us. You can contact myself if you want, or drop an email into the forum's website, and we'll see what we can do. So thanks again, everyone, and go check out the UAS for RS forum. Hope to see many of you there.
So thank you very much, Renee. I too would like to extend my thanks to everybody who's participated today. Just keeping an eye on the numbers here. I think we've had over 110 people from around the country participating, which has really indicated just how much interest there is in drone topics. And thank you, a particular thank you to our panelists, Arko, Jason and Christine. You've come from different perspectives, the research and the research infrastructure, operations in a government agency, and a company that is delivering services in this area, and the range of applications has really been terrific to see. Thank you very much, Renee, for moderating and interacting with the audience. I'd like to acknowledge the directors of the Advancing Earth Observation Australia Forum for the concept and the initiation of these webinars, and Larissa Marfan, the EO Partnerships Coordinator, who's really been the key organiser and driving the logistics with support from Sylvia Michael, the Earth Observation Australia Secretary. We'd really appreciate feedback from you in terms of the format, how you found this, the topics and so on, and Larissa will post a link in the chat window. So yes, we'd appreciate that. We look forward to seeing you in our future webinars. So keep an eye on our webpage and in your inbox for news about them. And also, we look forward to interacting more extensively, more deeply at our forum in August. Thank you very much, everybody.